and welcome to the part number 17. My name is Pavel Krzopla from blenderfig.com, and in this part we are going to continue from the last one, and we will finish the deserialization from the file, so we can go ahead and press Ctrl L and we can load up the file from the disk and restore our scene which we saved in the previous part. So I hope you're excited, and let's start coding. Okay, so we will just continue where we left off, and first I do want to create something little bit more interesting. So we can try something like this maybe. Put this one here, this one here. Okay, so maybe like this. This could be a little bit more interesting. I will press Ctrl S to save it to the file. Then I do want to commit this file. And let's try to save it again, if actually everything works. And as you can see, nothing has changed inside our file, which is awesome. So this one works, and we can go ahead to, let's say, to the scene itself, back to the end, and here when we are deserializing the whole scene, after everything is done, we will return true. And first off, we are going to clear the scene, so self clear. We do need to implement this method. We are going to initialize our hash map, and then we will go ahead and we will create nodes. After that we will create edges, and that's basically it. So the clear method which we will use or create for the scene will be pretty simple. Let's go above the save to file, define a clear, and we can basically delete all nodes one at a time. So while the length of self.nodes is gonna be bigger than 0, then we can choose the first node, so nodes, and in square brackets there will be 0, and we can remove the node. And this is perfectly working solution, because once we delete every node in the scene, every edges will be removed too automatically, because the sockets won't exist anymore. So this is basically done. We can go ahead and start creating nodes. So this one will be pretty simple. For each node data, in data, we are going to say, or maybe create a new node. We will pass the reference to the scene, and we will call the deserialize method. So maybe let me first import the node. So from node underscore node, import node, and we will basically need the edge too. So from node edge, import edge. And now we can call deserialize method, and we will pass node data and hash map. After all of the nodes created with all sockets, we can go ahead and start creating edges. So for each edge data, in data edges, we are going to create a new edge. We will pass the reference to the scene, and we will again call new edge dot deserialize, and we will pass edge data comma hash map. And we should be probably able to call it the same way we are calling the node. But for now I will comment this out because I do want to test if the nodes actually work. Or maybe let's try to run the program and it crashed. Okay, so for now I will comment this out. Let's try Ctrl L, and as you can see, immediately we got already 3 nodes which are undefined and without sockets. So basically the next place we are going to the node, down to the deserialize method, and here after everything is done we will return true. And first off we wanna set the ID, because when we create a new node it will get created with a new ID, but once we are deserializating the data we already got some ID inside. So let's say self ID will equal to data ID. Then we can go ahead and store the reference for this node to the hash map. So let's say hash map, and the key will be data ID, and the value or the reference will be this node itself. So this one is done. So that's for the ID. We can go ahead and set the title. So self title equals to data title. And let me check one thing. Yes, node title and QDM graphics node. If I check this one, there is, here is a property title and a setter which actually sets the text inside of the node. So I will copy these two properties and I will paste them to the node, because we want to do basically the same thing we are doing inside the graphic node. So once we set title or get the title, we will return the value. Once this title will be set, then we are going to say self gr node dot title equals self dot underscore title. Okay, and we need to make sure that we are setting the title after the gr node is already created. So let's try that, and it crashed because there is no property self dot underscore title. So let's set sum up underscore title equals to title. Let's start it again, and I press Ctrl L, and you can see we got my awesome node 3, 2, 1. Awesome. So setting up the title works. If we go down here, then we can go through the inputs and the outputs inside of our file, which is here. And as you can see, the inputs are already sorted at the index, starting from 0, 1 and going to 2. And the output, there is only one output, but if there were more inputs or more outputs, you should make sure that the index is being indexed from 0 and going up. In case it's not being correctly sorted out, we can make sure that the data will be sorted, and we can basically say something like data inputs dot sort, and we can pass a key. Here we can create lambda function and we can say that it's gonna be socket index plus socket position multiplied by, let's say, 10,000. Doesn't really matter. And this way we can make sure that once we get through all the inputs inside of our data, they will be sorted out by index correctly. We can do the same for the outputs. So just to be sure, we can use this. And now we can start creating inputs. In the start, it will be empty list. So for socket data, in data inputs, we are going to create the new socket. So new underscore socket will be equal to socket. The reference to the node will be self. Index is gonna be socket data and index. The position is gonna be socket data position. Then there is a socket type, and that's gonna be socket data socket type. But this way we will create a new socket with some random ID. So we can say new socket, deserialize and pass socket data and the hash map. So once we arrive here and we got our hash map, we can just basically copy paste these two lines, which will set up the ID of the object itself and store the reference to the hash map. So copy these two lines, go to the socket, go up here, and we can return true for now. And therefore, because everything else is being set here in the constructor, we don't need to deserialize anything else, which is maybe not a good idea, but for now it will be sufficient. And I forgot something. Yes, I definitely did. We need to say self inputs and append this new socket like this. So let's try that. Ctrl L, and you can see we got input sockets here. Awesome. The same will apply to the outputs. So self outputs will be empty. We are going through data outputs. We are creating a new socket, deserialize, and self outputs append new socket. So let's press play, Ctrl L, and you can see we got 3 nodes. We forget something, and that was the position X and position Y. So we can basically say self.set position data pos underscore X and data pos underscore Y. So let's try that, and you can see the nodes were reordered correctly as they should. So after we end, we can print out a hash map, so we can know, so we can check out what we are dealing with. And as you can see, inside of the hash map there is some kind of a code, so some index pointing to the node and other ones pointing to the sockets. So basically it looks like inside our hash map we do have nodes and sockets, and they should be all of them created, because I see there are more nodes and more than 4 sockets. So basically this should work. So hash map should be set correctly. Now we will go to the edge. I believe that's here. Yeah. And what do we have inside our edge? Our edge has ID, edge type, edge start and edge end. Basically we can go ahead and say self.id equals to data ID, self.start socket equals to hash map, with data start and the same will go for the end socket. And we forgot the edge type, so self.edge type will be equal to data edge type, like this. Okay, so let's test this. Ctrl L, and the nodes are not visible at all, because I believe we do have this commented, so let's uncomment it. Edge data, and we are creating edge without any values. So let's go ahead to the edge and let's have a look, because this will not be working at all. So we need to somehow fix this one. So to be able to create a new edge just with the scene parameter and empty start socket and end socket, we can say that by default these parameters will be none, like this. And I don't like this code here, because when we have an start socket being set to something, then we are going into the socket and we are setting the edge too. So basically we can create a new setter and getter methods for this. So let's define property. This property will be called start underscore socket, and this will return self dot underscore start socket, and start socket dot setter will be define start socket self value, and we are going to say self dot underscore start socket equals to value, and if self dot start socket is not none, then we are going to say self start socket dot edge equals to self. And the same thing will apply for the end socket. So end underscore socket, so end socket, end socket, end socket. How this one works? This way we can delete these lines and they should be working. So let's start it again. Yeah, everything still works. Let's press Ctrl L, and we got a crash because somewhere there is a problem. So let's continue with our cleanup. Basically, once we create the edge, we will define the edge type, and we will create this QDM graphic edge direct or Bezier, and we can change this later. And this is what I don't like actually. It would be really nice if we can just set the edge type itself, and it will automatically create the correct graphical edge representation, and we don't need to take care about anything else. So this class would be much more useful from outside. So let's try to do that. We can create a new property again, and this one's gonna be edge type, and it's gonna return self dot underscore edge type. And let's create a setter. Define edge type self value, and this one will be a little bit more complicated. So first off, in the case that we are actually having an edge already set up in the scene and we change the edge type itself, what we want to do is we want to destroy the graphical edge itself and remove it from the scene if it does exist already. So if has attribute self gr edge and self.gr_edge is not none, then we are going to call self scene dot graphical scene remove item self gr edge. So that's first thing we need to do. The second thing, we can basically set up the value, so self dot underscore edge type equals to value. This will work correctly, and then we can decide what type of edge we actually are trying to create. So if self dot edge type equals to edge type direct, we are going to say self gr edge is equal to qdm graphic edge direct, and we need to pass self. Else if, so elif self dot edge type equals to edge type Bezier, we are going to create self gr edge equals to qdm graphic edge Bezier, and we will pass self again, and I will duplicate this line because if the edge type was anything else, we will always create the edge type Bezier for this one. And once we create the graphical edge, we can say self dot scene dot gr scene dot add item self dot gr edge. Is it correct? It should be. And basically, let me have a look here. This way we don't need this line anymore. We don't need this line anymore. And what about the update positions? We can basically move this line below here, and we are going to update the position only if the self.start socket is not none. So if we know the start socket, we are going to update the position itself. So this one should be okay. This one too. So let's try that. When I start the application, it works. Awesome. Now I will press Ctrl L and look at that. We got our nodes being successfully loaded from a file. If I right click, you can see we got 3 nodes, 3 edges. So this one works. Let's test. These are connected correctly to the node itself. So finally we have finished our deserialization, and I hope you learned something. Thanks for watching, and see you at the next part.